So in this case, you've been told the lengths of metallic conduits in a shop were measured and recorded in this frequency distribution table. So we have the length in meters and grouped into classes. The first class 29.5 to 29.6, the second class 29.7 to 29.8, the next class 29.9 to 30.0, the next class 30.1 to 30.2, the next class 30.3 to 30.4, then the next class 30.5 to 30.6, then the last class 30.7 to 30.8. Then you'll be given the frequencies in each case. You'll be given the frequencies, the first class frequency of 3, followed by frequency of 6, the frequency of 11, frequency of 553, and the last there 2. Then you'll be told from this data, determine the mean length, the standard deviation, the median, and the mode. So for us to determine all these, then we need to construct a frequency distribution table. So when you are constructing the frequency distribution table, we start with the classes, isn't it? So the classes we have here are the classes. The first class is 29.5 to 29.6. Then the next class is 29.7 to 29.8. Then the next class is 29.9 to 30.0, isn't it? Then the next class is 30.1 to 30.2. Then the next class is 30.3 to 30.4. Then the next class is 30.5 to 30.6, isn't it? Then the next class 30.7 to 30.8. So we've represented the classes. So the next thing, we need the frequencies. We've been given the frequencies, the number of the metallic conduits in each and every class, isn't it? So the frequencies, we have our column of frequencies denoted by F. Then in this first class, we've been given a frequency of 3. Then the next class, a frequency of 6. The next class, a frequency of 11. The next class, a frequency of 5. The next class, a frequency of 5. And in this class, a frequency of 3. And in this last class, we've been given a frequency of 2. Isn't it? So when you sum up all the frequencies, you get the total number of the metallic conduits whose lengths were measured, isn't it? So how many are there if you sum up all the frequencies? If you add up all the frequencies, adding up all frequencies, you get 35. So it means there were 35 metallic conduits, isn't it? So after frequencies, we need X, the data value representing each and every class, isn't it? Each and every class must be represented by a simple value, and that X is the main point, isn't it? So what is the main point of this class? It is the average. 29.5 plus 29.6 divided by 2, isn't it? You get the main point to be 29.555. Then the main point of this class, 29.7 plus 29.8 divided by 2. You get 29.775. Then this next class, 29.9 plus 30.0 divided by 2. You get the main point there to be 29.995, isn't it? Then this next class, the average with 30.1 plus 30.2 divided by 2. 30.115. Then this next class, 30.3 plus 30.4. Then the answer divided by 2, you have 30.335. Then the midpoint of this class, 30.5 plus 30.6 divided by 2. 30.555, isn't it? Then this next class, 30.7 plus 30.8 divided by 2? 30.775, isn't it? So, you know, we are going to look for the mean, we are going to look for the mean, the standard deviation, the median and the mode. So if you're looking for the mean is going to be what? We are going to sum up all the data values and the number of times they appear, and then we divide by that total number, isn't it? Meaning the moment we are going to look for the mean, we are going to have the column of f, the column of fx, isn't it? So we need a column of fx, f times x, because here we don't use a simple mean, meaning there's no d here, isn't it? There's no another variable, isn't it? So f times x, 3 times 29.55, 88.65. Then you move again, 6 times 29.75, 178.5. Then the next, 11 times 29.95, 329.45. Then the next class, 5 times 30.15, 150.75. Then the next class, 5 times 30.35, 151.75. Then the next fx, 3 times 30.55, 91.65. Then the next f times x, 2 times 30.75, 61.5, isn't it? So it means when we are going to look for the mean, we are going to have the fx, isn't it? And when we are going to look for the standard deviation, it is going to be the square root of variance, isn't it? Meaning we must have fx squared, isn't it? When we are looking for the variance, we must have the fx squared. So you start fx squared, it means it is fx times x. Are you seeing? Fx times x, you get fx squared. So you start fx times x, 88.65 times 29.55, you get 88.65 times 29.55,
2619.
2619.6, 6075, isn't it? Yes. Move to the next one, fx times x to give you fx squared. 178.5 times 29.75. 5310.375. You move to the next one, fx times x, 329.45 times 29.95. 9867.0275. You move to the next one, fx times x to give you fx squared, 150.75 times 30.15. 45. 125, isn't it? Then the next 151.75 times 30.35, you get fx squared to be 4605. 4605.6125, isn't it? Then the next 91.65 times 30.55, 907.75, isn't it? And you move to the next one, fx times x, 1161.5 times 30.75, 1891. Yes, 1891.125, isn't it? Then the next, we are going to look for the median, isn't it? So when we are going to look for the median, we need the cumulative frequency C, isn't it? So for you to get see, in this first row, the frequency is 3, meaning you've counted 3 zero. Then in this next row, you've counted 3 and you are counting 6 more. Meaning at the end of this row, you have counted a total of 9. Then at the end of this row, you've counted 9 and you are counting 11 more, isn't it? So at the end of this row, you have counted 20. Then at this row, you counted 20 and you are counting 5 more. And then you have counted 25. Then at the end of this row, you counted 25 and you are counting 5 more. You have counted 30. Then at the end of this row, you counted 30 and you are counting 3 more. And then you have counted how many? 33. Then at the end of this row, you counted 33 and you are counting 2 more. And then you have counted how many? 35. Meaning, if you counted 35, the last term was the 35th term. And you can see all the frequencies what? 35, isn't it? So from there, you now need to get your summation fx. If you sum up all the fx, isn't it? So if you add up all the fx, what do you get? Then you go again. If you add up all the fx squared, what do we get? So it is good to analyze the table so that when we are going to the question, we have a complete table, isn't it? Yes. And it is what is required, it is what is guiding you which columns to have, isn't it? Yes. Are we together? So start by adding up all the fx. If you add up all these fx values, what do you get? 1052.25, isn't it? You get 1052.25 if you add up all the fx. Again, if you add up all the fx squared, you get what? If you add up all the fx squared, you get summation fx squared. You get to be. If you add them up, what do we have? Add up all the fx squared. You have
31,636.
636 and 36
27,675.
76775. So you have the same values. It is the same value confirmed, isn't it? Good. So after we found all the summation fx and summation 31
638.
31,638.
Yes.
Point
7,675.
So once you have all the values, you now start answering the questions, isn't it? Yes. So the first one, you will be told to find the mean length, isn't it? So the mean, if the lengths are denoted by x, then the mean is denoted by x bar, isn't it? And the mean is what? Summing up all the x values and dividing by their total number. Meaning it is summation fx divided by summation f. Are you seeing? Yes. Summation f is the n. So this n, the total number, is adding up all this frequency. So it is summation fx divided by summation f, isn't it? Are you seeing that? Yes. So you get the mean to be 1052.25, which is summation fx. Then it is over the total number, which is summation f, to be 35. So you have the mean of x to be what? 30.06. You have the mean is 30.006, isn't it? After that, you get the standard deviation. So before the standard deviation, you have to get the variance of x. So the variance of x is the mean of x squared minus the mean of x squared, isn't it? So the mean of x squared is what? Is summation fx? It is summation fx squared divided by that total. It is this summation fx squared divided by that total number, isn't it? Then it is minus the mean squared. Are you seeing that? Are we together? If you are getting variance, it is like saying it is expected value of x squared minus expected value of x, which is the mean, then squared. So from here you can see expected value of x squared means the mean of x squared. The mean of x squared means you are summing up all the x squared and you're leaving the total number they are appearing over their total number, which is the summation of x. You get that, isn't it? Then it is minus expected value of x is the mean of x, and the mean of x is just x plus then it is squared. So the variance is f of x summation fx squared divided by summation f, isn't it? Then minus the mean squared, because you already found the mean. Are we together? Good. So if you are together, can you now substitute those values to get the variance? So the variance is going to be, where there is summation fx squared, we found it to be what? 31? 31, 630? 638.7675. Then divide by their total number. Their total number summation of f we found to be 35. Then it is minus the mean squared. Never forget, because we derived this formula, we found out it was coming out to be mean squared, isn't it? So this is 30.06 squared. So if you work out this, what do you get to be the variance of x? The variance of x is 0.361, just like that. Are we together? You have a different value?
No, it's the same, but that's
Oh, you have 0.361?
11857.
So where you want to round it off, because you don't be told, like in our case, she has left the converses, in your case you can live for 5, so long as you don't be told, isn't it? Yeah, but for significant figures it's very convenient. So 0.3611. So it is 0.3611 for significant figures, isn't it?
0.3612.
So it was 118. So that one we rounded off to 2. Good. So after getting the variance of x, we can now get the standard deviation, isn't it? So standard deviation is the square root of the variance. So you get the standard deviation to be the square root of 0.36112, and you get it to be what? 0.601. So that is the standard deviation. So the mean length you found is 30.06 meters, because you are told the length is in meters, isn't it? So that is the mean length. Then the standard deviation, even if you don't do the meters, there's no problem, okay? The standard deviation is 0.601. Now we need to look for the median. Are we together? Let us now look for the median. So that is how to determine the mean and the standard deviation. Let us see how to deal with part C, the median. How do we get the median? So the median is given by the lower class limit of the median is given by the lower class limit of the median class plus n over 2, which represents the median. It does not mean you take n and you divide by 2, isn't it? N over 2 is used to denote the median. Then it is minus c, which is the cumulative frequency of the class above the median class, because we are using the rank order from lowest to largest data value. Then it is over the frequency of the median class, then the whole of that is multiplied by the class interval of the median class. We derive that and we show how it was coming about, isn't it? Now, we need to know what is n minus 2, which one is the median value, it is occupied which position, isn't it? So n, first of all, you need to know what n is. So what is n? N is the summation f, isn't it? N is the total number, summation f, meaning n is 35. Are we together? N is 35. 35. Now, when you're looking for n over 2, which is denoting the median term, n over 2, it is given by n plus 1 divided by 2. You know when n is odd, you have exactly one value in the middle, isn't it? And when n is equal, there are two values in the middle, isn't it? So if n is equal, if you got where n was 20, then the middle value are going to be two values. 20 divided by 2, which is going to be the 10, and the 11 term. Two values are going to be the middle if n was 20. Isn't it? The 10 and the 11 term. So when you're looking for the median, you take the average of the two 10 plus 11 term, meaning you're looking for the 10.5 term, isn't it? Are we together? So that represents the median. So if you get this 10.5 term, it is like saying n plus 1 divided by 2. So 20 plus 1 divided by 2, you still get 10.5. Whether it is equal, odd, or n over 2 is just n plus 1 divided by 2. Meaning we are taking the average of the two values together if n was equal, isn't it? But if n was odd, then there's exactly one value in the middle, isn't it? So n over 2 is used to denote the median, but the median value is now given by n plus 1 divided by. Are you seeing that? This is how to get the value, but n over 2 means the value which is halfway in the distribution. It is denoting the median. Are you seeing that? But this is denoting the median, this is denoting the median, then this is defining that value, that term. Are you seeing? Are we together? So n plus 1 divided by 2, 35 plus 1 divided by 2, you get? 18. The 18th term. So it means the value in the middle is the 18th term when they are 35. Are you seeing that? Are we together? Yes. You've seen what has happened there? Now this is now what you know. N divided n over 2, which is represent the median, where it is, you put a 18. So you are going to have your median to be L plus 18 minus C over F into I. Because n over 2 we found it to be 18. N over 2 is used to denote the median, but getting the median is n plus 1 divided by 2. Only the median is special, isn't it? The rest you are taking direct. If it is lower quartile, it is just a quartile the way it is, isn't it? Yes. If it is upper quartile, it is just 3 quartile the way it is, isn't it? So it is only the median where there are two values in case of even and one value in case of order distribution, isn't it? Are we together? Yes. Now, for you to know the median class, C must be less than 18. Are you seeing? C must be less than 18. Because our rank order was from lowest to largest. So you go to the C column and you start from downward. You look until you get a value which is less than 18 from downward. Which value is less than 18? Which one comes first? 9. Are you seeing? 9 is less than, it is 18 minus, meaning C must be less than 18. Are you seeing that? So once you identify C to be 9, meaning the median class is the class below it. Are you seeing that? Because C is the cumulative frequency of the class above the median, meaning C is above the median class. Are you getting that? So it means once you've identified C to be this class, meaning the class which is below is the median class. So the median class is the class of C is this, the median class is this class. 29.9 to 30.0. That is the first way to deal with it. Are we together? The class of 29.9 to 30.0. Is that okay? Yes. Have you seen how to identify the median class? Yes. Yes. Now, after that, we now come and rewrite that class here. It is 29.9 to 30.0. Now look at what you are going to do here. Once you identify the class is 29.9 to 30.0, this is what you are going to do. You are going to check. This class started at 29.9. The other class ended at 29.8. This ended at 29.8. This one started at 29.9. So the average there gives you the class limit there. Are you seeing? So 29.8 plus 29.9 divided by 2 gives you the lower class limit here. Are you seeing? Which is 29.8. 5. So remember, the other way I wanted to explain the other way of getting that median class. When you take this 18th term, you just go to the C direct. This is what this means. That is what I want to explain. This means you counted up to 3 the last time you counted there is the third term. Are you seeing? This means you counted the last time, the 9th time is the last time you counted. You see what it implies? Then if here is 20, it means the last time you counted there is the 20th time. To go forward. Yes. Then if here is 25, it means the last time you counted there is the 25th. So you can see, if the last time you counted there is the 9th time, meaning the next time you started counting here was the 10th time. Are you seeing that? Yes. So from 10th time to 20th time is in this class. And you can see 18th time is between 10th time and 20th time. It is here. Are you seeing another way of identifying it? Yes. Are we together? Yes. Serious? So you can use either way. Either C must be less than 18 for you to identify the C class, then the median class is below it. You would have seen it, isn't it? Apart from that, you know the median is the 18th term. So you go and see where is the 18th term along the C, isn't it? Meaning if here you can see, if here it means the last time you counted there was the 35th term, isn't it? So the last time you counted here was the 33rd term. So it means here you started from the 34th term. So it means this cumulative frequency column tells you the position of each and every term. So you now come and see where is the 18th term. Then you'll be able to see 18th term is between 10th to 20th term. But the reason why this is the best way, checking the value which is exactly less than 18, because sometimes you find 18 in the boundary. Are you seeing that? Sometimes what you found that here C here is 18. So if you found C here to be 18, then we are saying C to be less than 18. Then we need something which is above. We are going to use this idea to eliminate the ambiguities. Are you seeing that? Yes. Are you together? But we're looking for the term number, the position of each and every value still works the same case by looking for either C or the 18 term. You will still see the class, okay? Is that okay? Yes. So we've seen the median class is 29.9 to 30.0. So if you want the lower class limit here, this is class boundary at 29.9, but the other class ended at 29.8. So you see, the other class ended at 29.8, and this one started at 29.9. So the average here gives you the class limit there, isn't it? Are you seeing that? Then it is up to this, our median class has ended at 30.0, and the other class has started at 30.1. So the average here gives you the class limit there. Are you seeing? Which is 30.0 plus 30.1 divided by 2 gives you the upper class limit of that our median class. You get it to be 30.05. So are you seeing how to get the class limits? Meaning you must first know the class and you write the class, isn't it? There's a time when the class boundaries are the same as class limit. The class boundaries will be the same as class limit if this class ended at 29.8 and this class started at 29.8. Meaning this 29.8 plus 29.8 divided by 2 still get the same 29.8, isn't it? See, that is a case when the class boundaries are the same as class limits. But in this case, the class boundaries are different with the class limits because we have different values at the boundaries, isn't it? Are we together? Is that understood? Good. So it is from the class limits where you get the class interval, because the class limits is what is telling you the extent the class can stretch, the weight of the whole class, isn't it? So the class interval is the upper class limit minus the lower class limit. What do you get to be the weight of the class or the interval? 0.2, isn't it? Then we also need the frequency of this class. You know, we are getting everything for the median, isn't it?
It was 29.95.
It was 29.95?
Yeah.
It cannot be 29.95. This one ended at 29.8 and this one started at 29.9. So average of 29.8 plus 29.9 divided by 2? 29.85. 29.85.
Yeah.
Look at it. So what is the frequency of this class? Because we also need F, isn't it? The frequency of that class, you go under the F column. So what is F of the class? It's what? 11. It's 11. Now the only thing we are left to get the median is to substitute the values we found, isn't it? So the median is what? The lower class limit of the median class. What have we found to be the lower class limit? 29.85. Then it is plus 18 minus C. 18 minus C. C was the class, the C cumulative frequency of the class above the median class we found was 9, isn't it? So it is going to be 18 minus 9, which is 9 over F. F we found to be what? 11. Then the whole of that is times I. I we found to be 0.2. So if you work out that in the calculator, what do you get in the median? Just take 29.85 plus 9 of 11 times 0.2, isn't it? What do we have? What have you found? 30.0? 30.01. You go the extent the class limit is reaching. Class limit is to 2 decimal places. Meaning this value must be to 2 decimal. Are you seeing that? Because that is what we have in the class limits, isn't it? Are we together? So it is 30.001. So you see now to see the median. You can identify the heat term by looking at the positions of C, or you can identify the median class by getting C first, isn't it? Then the median class is below C, which is the cumulative frequency of the class above the median class, isn't it? Are we together? Now we've now determined the median to be 30.01. We now want the mode, okay? How do we determine the mode? Now the mode is very simple. It is just from this formula of the median. If you use the formula of this median to get the mode, you simply wrap what is inside here, isn't it? You simply wrap what is inside that bracket, and it becomes D1 over D1 plus D2, and that is the mode. So it will be the lower class limit of the model class plus D1 over D1 plus D2 into the class interval. We want to know what these D's are, okay? Now those D's are the difference in the frequency. D1 is above, D2 is below, isn't it? So you go to the frequency, they represent the frequency. So if the frequency of the median class, this is the median class, are you seeing this? If the frequency of the median class, you denote it with F, then the frequency above it, you denote with F0, and the frequency below it, you denote with F1. Are we together? So when you are now looking for D1, D1 is the frequency of the median class minus the frequency above it, meaning D1 is in the middle there, D2 is below. Are you seeing that? So D1 frequency of the median of the model class, I mean. You know, we've not identified the model class, first of all. I've identified it, yes, but I've not explained how it is coming about. Yes. The model class is the class with the highest frequency. Meaning this is the model class because the frequency is 11. So that median class has happened to be the model class. Mode, you now look for the frequency. Are you seeing that? Yes. Are we together? Yes. So before you start, you identify the model class before you get the mode. Because it is the model class giving you the mode. Are you getting that? Yes. So the model class is the class with the highest frequency. So if you look at the frequency, the highest frequency is 11. Meaning what is the model class? 29.9 to 30.0. Then after we've identified the model class, we identify its class limits, isn't it? Now this class, model class, started at 29.9. The other class ended at 29. So the average there gives you the lower class limit, isn't it? So what is the average? 29.8 plus 29.9 divided by 2? 29.85. Then our model class has ended at 30.0, the other class has started at 30.1, isn't it? So the average there gives you the upper class limit, isn't it? Which is 30.05. That is 30.0 plus 30.1 divided by 2, isn't it? Are we together? 30.05. So from there, we now want to identify the D's, isn't it? So our 11 is here, meaning the frequency, the D1 is going to be on top and the D2 below, isn't it? So what are we saying is D1? The frequency of the model class minus the frequency above it. So if you can say the F minus F0, there's no need once to know how it is coming about, isn't it? You just say D1 is 11 minus 6. Frequency of the model class minus frequency above it, isn't it? 11 minus 6, you get 5. And D2 is the frequency of the model class minus the frequency below it, isn't it? So the frequency of the model class is 11 minus 5, meaning this frequency of the model class is what is subtracting everything, isn't it? 11 minus 6 to give D1, 11 minus 5 to give D2 down. Are you seeing that? Yes. That is going to be 6, isn't it? Then the class interval we get from the upper class limit minus the lower class limit give us the class interval or the class weight, isn't it? The class weight cannot be getted from the class boundaries because some classes, you can see there are gaps, and those gaps are only sealed with the limits, isn't it? Are we together? It is the limit which shows the extent a class can stretch. So 30.05 minus 29.85, you get the class weight, which is 0.2. So after you determine everything, you substitute in the formula, isn't it? So the mode is lower class limit of the model class, and the lower class limit you found to be what? 29.85. That is 29.85. Then it is class D1. D1 you found to be 5. Over D1 plus D2. 5 plus 6, isn't it? D1 plus D2 you found is 11. Then it is times I. I you found is 0.2. So what is the mode? If you work out that in the calculator, what is the mode? What do you get to be the mode? 29.85 plus 5 of 11 times 0.2. You have 29.94. You have 29.94 to be the mode. So that is how to determine the mode. Are you together? So you have to know how to get the mode, the median, the mean, and the standard deviation. Let us see another case.